At 1:04 in the afternoon, the control screen showed about 8 feet of liquid inside the tower. The real level was 158 feet. The tower was almost completely full, but the number on the screen was going down. One alarm had already been acknowledged. The backup alarm was broken. And only 16 minutes later, the refinery exploded. 15 people died. 180 were injured. So, how do you accidentally feel a tower taller than a 15-story building and not see it? Well, the answer is not one stupid mistake. It is a whole system slowly teaching people that danger is normal. This is Failure Atlas, and this is the story of the BP Texas City refinery explosion. Okay, first, forget the complicated refinery language. The machine at the center of the story was basically a giant metal kettle. Fuel entered the tower. Heat separated the lighter parts from the heavier ones. One part left near the top, the other left from the bottom. The tower was called a raffinate splitter. But you only need to remember one thing. Liquid goes in, liquid must also come out. It is like filling a bathtub. If the tap stays open and the drain stays closed, well, you already know what happens. And on March 23, 2005, fuel was flowing in. Almost nothing was flowing out. The restart had begun during the night. Then the night crew stopped halfway through. That was unusual, and the instructions did not explain how to continue from there. When the morning crew arrived, they received almost no useful information. They did not know exactly what was already full. They also received mixed messages about which storage tank could accept the fuel. So the morning crew continued the restart. The inlet opened. The outlet stayed closed. And here is the really dangerous part. The control screen still showed fuel leaving the tower. But it was not. The crew was filling a huge container with no working way to see the total amount inside. And they were about to turn on the heat. The tower was 170 feet tall, but its level meter only watched a tiny section near the bottom. Once the fuel rose above that section, the crew was basically blind. And yeah, people already knew the meter was inaccurate. There was a glass level display outside the tower, but it was too dirty to read. There was also a separate high-level alarm that was broken too. Technicians had started checking the alarms before the restart. Then a supervisor told them there was no time to finish. The paperwork was signed on anyway. Just think about that. They were starting one of the most dangerous operations in the refinery, with the very equipment needed to see the danger already known to be unreliable. Then fuel entered the tower for more than 3 hours. The crew believed some of it was leaving. For almost all of that time, it was not. At 12:42, the screen suggested about 8 feet of liquid. The real level was around 140 feet. 22 minutes later, the screen showed slightly less. The fuel had climbed to 158 feet. The liquid was rising. The number was falling. And from the control room, everything still looked manageable. Now, the heat made everything worse. The hot fuel expanded until it reached the top of the tower. Then it spilled into a pipe meant to carry vapor. The pressure rose, and 3 emergency valves opened. Those valves saved the tower from bursting, but they sent the disaster somewhere else. The fuel rushed into an old collection drum connected to an open stack. A safer system would send dangerous material to a flare and burn it high above the ground. This stack had no flare. It opened directly into the air. For more than 6 minutes, liquid poured into a system that was far too small to hold it. The drum filled. then the 113-foot stack filled. And finally, fuel burst from the top like a geyser. It rose about 20 feet into the air. Then it rained down through pipes and metal structures. The falling fuel broke into tiny drops and created a huge flammable cloud close to the ground. Workers saw it. They called the control room. The operators began shutting down the heat. But by then, the countdown was almost over. A diesel pickup truck was idling only 25 feet from the blowdown drum. As the vapor reached it, witnesses heard the engine suddenly race. Investigators believe a backfire from that truck was the most likely spark. At exactly 1:20 seconds, the cloud ignited. The explosion ripped through the refinery. Homes were damaged 3/4 of a mile away. And sitting beside the unit were temporary office trailers used by contract workers. Some were only 121 feet from the blowdown drum. They were placed there because it was convenient. They did not need to be there. Every person killed was in or around those trailers. 15 people never went home. Now, you could blame the operator watching the screen, but honestly, what was he supposed to trust? The level meter was wrong. The flow reading was wrong. The outside display was unreadable. The backup alarm was broken. And he had worked 12-hour shifts for 29 days in a row. No days off. Other experienced workers had been doing the same for even longer. This was not one careless person. It was a tired crew trapped inside a badly designed system. And the refinery had seen warnings before. Between 1994 and 2004, this same blowdown system was involved in 8 serious incidents. 2 caused fires. 6 created dangerous vapor clouds near the ground. Some were barely investigated. Important fixes were never completed. So, the final explosion was not a surprise, but it was the warning they failed to survive. The official investigation found problems at every level of BP. Maintenance level had suffered, budgets had been cut, production kept moving, and the company often measured safety through smaller injuries like cuts, slips, and falls. Those numbers matter, but a low injury number cannot tell you that a tower is filling with fuel behind a broken alarm. That is what makes Texas City so important. The tower did not need one perfect operator. It needed layers of protection. The meter should have worked. The alarm should have worked. The restart should have stopped. The fuel should have gone to a flare. And the trailers should never have been there. Any of those protections might have changed the ending. Instead, every one of them had already been weakened. Texas City did not run out of warnings. It ran out of changes to ignore them. You know, disasters like this always look sudden, but they usually are not. The explosion lasts only seconds. The real failure can take years. If you want to uncover more stories like this with me, subscribe to Failure Atlas. And now you choose our next stop. Which disaster should we put on the map next?